Hi, my name is Swapnil Nicholson Radal, and today I'm going to present my project on Spotify product dissection and Postgre database design. And in this product project, I studied Spotify not only as a music streaming application but real world business product. I analyzed how Spotify works, what problems it solves, and how its data can be stored efficiently using a relational database. After understanding the product, I designed a fully normalized Postgre database schema consisting of 11 core entities. I also performed data cleaning, exploratory data analysis, business insights generation, advanced SQL analysis using PostgreSQL. So throughout this presentation, I'll be explaining why I made each design decision and how the database supports Spotify major features like music streaming, songs, playlist, recommendation, subscription, listening history. And before we begin, let me just briefly explain today's agenda to you. First, I will introduce Spotify and explain why I selected it for this project. Next, I will be discussing Spotify business model, its core features, and the real world problem that it solves. After understanding the project, I will be explaining the database schema that I designed using PostgreSQL. I will also explain the entity relationship diagram, also called as ER diagram, and describe how tables are connected. Then I will be discussing the SQL workflow that I followed. This includes loading the data set, checking the quality of the data, performing exploratory data analysis, and then generating business insights from it and writing advanced SQL queries. And finally, I will be explaining the optimization technique in this database and summarize the key learning from this project. And let's move to the next slide. So before understanding the Spotify, like the data set, let me just make you understand what was the music streaming industry before. In the past, people used to purchase CDs or download songs from different pirated or non-pirated websites. So every song has to be stored to the user's computer or mobile phone. So this consumed storage space and made managing music collection very difficult. So as a internet as internet speed improved, cloud technology became popular. And instead of downloading songs permanently, users could simply stream music through the internet whenever they wanted. So this completely changed the music industry. Today, millions of users prefer streaming because it gives instant access to the huge collection of songs without worrying about the storage space. Another major change is personalization. Modern streaming platforms do much more than simply play the music. They analyze user behavior. For example, they study what songs a user needed to listen, and based on the match and their interest, uh, the app usually show the recommendation list. So Spotify is one of the best example of data driven platform, as it is having recommendation system consistently, which consistently learns from the user interest and improve the listening experience. So this is one of the main reason why I chose Spotify. And beside it, like Spotify usually the one of the world's leading music streaming platforms. Now let's move to the next slide. So now the question is why I chose Spotify. So I selected Spotify because it is an excellent example of data driven product. Spotify was founded in 2006 in Sweden, and the goal of this product was to make easily accessible music app which can be accessed through internet streaming instead of downloading it. And today, Spotify serves hundreds and millions of users around the world, providing access to the music, not only just music, songs, but podcast as well as audiobooks across many devices such as smartphones, laptops, tablets, smart TVs, gaming consoles, and some smart features, smart earphones or smart speakers. So one of the Spotify's biggest strength in free business model is like they are being provided with two subscription model. This means like it has two choices whether the user want the free plan or the premium plan. As for the free plan, user can listen to the music or listen to the podcast without paying single penny from his pocket. However, they can hear advertisement from it and has a limited control over the playback and cannot download the songs after listening it. And a premium user can have the access of monthly subscript by paying monthly subscription fee, and in return they can be getting ad-free listening experience, offline downloads, unlimited skips, and better audio quality as well. So this business model is successful because free users help Spotify attract large number of audience, while premium user generates recurring revenue. So Spotify also creates value for the artist because like before it like usually artists need to sell it by selling their CDs, and like this was very hectic thing usually in back days artists had. So in the new world, artists can publish their music to the global audience and earn revenue from the streams, while user gains legal convenient access to million of songs. And from a database perspective, the Spotify is an excellent case study because every action like creating an account, following the artist, downloading the songs, or listening uh, to the particular song, like making the playlist from it, purchasing the subscription, and receiving recommendation creates structured data, and that data can be stored accurately and efficiently. That is why Spotify is very good example for learning database design and SQL. So now let's move to the next slide, and now we're gonna understand like why it is suitable for this project and why this uh, for the database design it's the best for case study. Now in this slide, I will be explaining what product dissection is about. So a product dissection means understanding how product works, like what is the value it provides to the user and how it solve real world problems. So Spotify is much more than a music player nowadays. Like it is like digital entertainment platform that offers music, podcast, audiobooks through cloud streaming. And users uh, don't need to download the song permanently because they can access million of tracks instantly by just internet connection. So one of the biggest strength is personalization. Every user has different music preferences, like and like preference not only in music but the different genres, and Spotify analyzing usually analyzes the listening history of the particular user by recommending the same genre taste which they like they had listened in the past, or like what are the name of the artist they usually follow, and based on the user's interest, like it usually recommends the user to the taste. So this create unique experience for every listeners. So Spotify also allows user to create playlist different situations such as while like mostly user like to listen to listen to music while studying, exercising, traveling, or just relaxing. So user can share their genre with friends or create collaborative playlist where multiple people can add song. Nowadays, like most of the people, like they usually share their Spotify playlist on different platforms. Like they are suggesting a different user to listen what kind of genre they are listening nowadays. And from a business perspective, Spotify collects valuable data whenever users searches songs, create playlist, listening to music, or subscribe to premium plans. This data helps Spotify to improve recommendation, understand user behavior, and make better business decisions. So this combination of streaming, personalizing, and data-driven recommendation is what makes Spotify one of the best, like not one of the best, but also world's leading music streaming platform. So now let's move to the next slide. So now let's discuss the core features of Spotify. So the first and most premium feature is like giving a particular plan, and like for example, it allows music streaming. So Spotify allows users to search for the particular song, particular artist, particular album, particular type of podcast and audiobooks, and play them instantly without downloading them permanently. So premium users can download like a number of movies to their offline library. And the second feature is playlist management. So user can create unlimited playlist, give them some name, add or remove songs from it, organize, and according to their mood or activity, a single like they can perform a lot of things, and single song can appear in many playlists, and that is why database use separate playlist tracks table to manage a many to many relationship. And the third feature is personalized recommendation. So Spotify studies listening history, favorite artist, genre, and playlist to recommend songs through features such as like the weekly basis, daily mix, or release radar. Like like we usually find these kind of like a recommendation from the Spotify every week. So this improves user engagement because user continues discovering new music, like new song, new artist, and a different genre. And the fourth feature is subscription plan. So Spotify allows a free model also where a user can freely listen uh, to the favorite song, and premium model also. So in free premium, user usually receive benefits such as ad-free listening, offline downloads, better audio quality as well, and and a lot of new features also in that. So this subscription model is one of the main sources of revenue of Spotify. So these four features are the foundation of the database design because uh, uh, every feature generates data, and that data must be stored somewhere, managed and analyzed efficiently. So now next, let's move to the next slide. So this slide is all about the real world problems. So I will be explaining the real world problems that Spotify solves in this. So the first problem is limited access to the music. So before streaming platforms became popular, user had to buy CDs, purchase individual songs, and this was expensive and required storage spaces, and Spotify usually solves it. Like nowadays, there is no need to buy CD from a store. Like you can easily take a plan, take a premium plan from Spotify and enjoy like unlimited songs of your favorite artist. So, like this, Spotify gives users instant access to millions of songs via internet, and based on a different model, like free or premium, like uh, like the user the user can buy plans based on their convenience. And the second problem is difficulty in discovering new music. So, with millions of available artists, and users often listen to only familiar artists because finding new music takes a lot of effort. And Spotify solves this by analyzing listening behavior, recommending songs that matches to user interest, and this allows uh, new artists reach more new listeners. And the third problem is organizing music collections. So people listen to different music depending on their emotions, mood, work, exercise, or the particularly the particular uh, like they mostly listen to music while traveling, and this is the only reason why the cars are giving infotainment system nowadays. And like Spotify allows user to create playlist, edit them, share them with friends, and even collaborate on playlist together. And the fourth of the problem is like personalized listening experience across multiple devices. So today users switches between mobile phones, laptops, tablets, smart TVs, etc. So Spotify stores playlist, listening history, user preference in the cloud. So allowing user to listen exactly where they stopped. Like for example, like I want to listen to some music in my laptop, and like before that I was been listening in phone, so I can easily like log into my account and start listening from where I stopped. So now let's move to the next slide. So this slide is all about like why I chose Postgre. So first reason is it follows relational database model. So data are being stored in table format, having primary key, foreign key, etc. And the second reason is PostgreSQL provides ACID properties, which ensures reliable transaction. And like in ACID is for atomicity, which means transaction either completed successfully or not. C is for consistency, meaning our database always remains valid, and I means isolation. Multiple user can perform operation at the same time without affecting each other. And D is for durability, which means like once the data is being saved, it will remain stored even if the system crashes. So these are the features why I chose Postgre. So now let's move to the next slide. So after understanding about the product, I designed normalized PostgreSQL database schema. So the schema contains 11 core entities which have been stored in table format, one specific type of information, and reduce duplicate data. And next is users table, which stores information about every registered Spotify user, including username, email, password, country, etc. And apart from it, there is artist tables, which stored information about singers, music creators. Then next is albums, and this table stores album released by artist. Then next is genre table, which classify the tracks into different music categories. The tracks, then the next is the track table, and it is the one of the most important because it store details such as track name, duration, popularity, energy, tempo, etc. And next is playlist table, and this store playlist created by the user. And next is listening history. So this table stores every song played by user. This is useful for recommendation system and to basically you to understand user behavior. And next is subscription plan, and this it stores available premium plans. And next is subscription table, which stores which user has purchased which subscription, whether active, expired, or cancelled. So let's move to the next slide. So while designing the database, main objective was to create structure that is simple, scalable, and efficient. So for achieving this, I designed the database using 3NF, that is third normal form, and normalization. Let me give you what is normalization. So basically, normalization is a process of organizing the data to reduce the redundancy and improve the consistency. Also, uh, also why I selected third NF, because Spotify stores a large amount of data, interconnected data. If the artist information, album details, genre information were repeated in every track record, the data will be adding unnecessary duplication. So this design uh, requires storage requirements, improving consistency, simplifies updates, and minimizes the possibility of data anomalies. And to maintain data integrity, every table has primary key, and it is also having foreign key to connect different tables and ensure the valid relationship between them. So now let's move to the next slide. So this is about ER diagram. So the first relationship is between users and the playlist. So and like this is having one to n, that is one to many relationship, and like user ID acts as a primary key, and user table in the user table, and foreign key in the playlist table. So, and the second relationship is between playlist and the playlist tracks. So, as one playlist can contain many songs, and like one playlist is connected to many records and the playlist tracks table. And the third relationship is between tracks and playlist tracks. So so there is many to many relationship between playlist and tracks. And the fourth relationship is between users and listening history. And the next relationship is between tracks and listening history. And sixth relationship is between artist and albums. One artist can release multiple albums, but one album can't have more than two artists in it. So the seventh relationship is between albums and tracks. And the eighth relationship is between artist and the tracks. And the ninth relationship is between genre and tracks. And the tenth relationship is between users and subscription. And like many purchase is different with different subscription plan. And the 11th relationship is between subscription plans and subscription. So one subscription plan can be purchased by many users. So now next move to the different slide. So this slide is all about the SQL overflow. So it is like basically like how I like imported the data set, then made tables, then EDA, then business insights, then normalized schema. So now let's move to the next slide. So why I did EDA? Because like EDA is best for building reports or dashboards and like finding the useful patterns and understanding the data set. So based on exploratory data analysis, I made some business insights from it, like popular artist, popular genre, duration analysis, explicit songs, etc. So now let's move to the next slide. And now next slide is about like I did advanced PostgreSQL. So in this I did CT, that is common table expression, Windows function, row numbers, and tile indices, and how to optimize the query. Now let's move to the next slide. So in this slide, like this usually show what I learned about like how I made schema design, what helped me making schema design, how normalization helped me, how query optimization helped database be efficient and fast, and like different analytics skills also. Now next move to the next slide, that is conclusion. So this project usually demonstrate how database design and SQL can be used to build scalable system and convert raw data into meaningful business insights. And now next, let's move to the next slide. So this is how I conclude my project, and thank you for your time and attention.